In ITE 140, financial functions are some of the most important functions that we learn, mainly because they're used every day by professionals who work in the accounting, finance, and banking industries. They're also used by anyone who just needs to know a little bit more about the process of borrowing money or saving money, especially in terms of how much a loan will cost you or how much you will receive if you're saving money after a certain period of time. This tutorial explains 3 financial functions that are used to create an amortization schedule. An amortization schedule is a complete table of periodic loan payments that shows the amount of principal and the amount of interest that make up each loan payment throughout the term of the loan. It helps you to determine how much principal is still owed on the loan or how much interest has been paid at a given point in time. It also helps you to calculate the total interest paid on the loan after all payments have been made. Excel has 3 financial functions that help you to develop an amortization schedule. The PMT function helps you to determine the monthly payment. The PPMT function helps you to determine the amount of principal included in the monthly payment. And the IPMT function helps you to determine the amount of interest included in the monthly payment. So let's review some amortization schedule terminology. First of all, the PV stands for the present value, and it is also known as the principal or the loan amount, how much you plan to borrow. Second is the rate. The rate is the annual interest rate, also known as the annual percentage rate or APR. It's the yearly interest rate given by the bank. NPER is the number of periods. How many payments are you required to make on the loan? And then PER specifies the specific period and must have a value between 1, which is the very first period, and then NPER, which is the total number of periods you make on the loan. FV is future value, and it will tell us how much the investment is worth at the end. For a loan, it should be 0 once we pay it off. And then type is a logical value representing 1 for loan payments made at the beginning of a period, or 0 for payments made at the end of a period. The PMT, PPMT, and IPMT functions help us to make the amortization schedule, and we need to use or know these terms in order to set up the functions properly. Earlier we had a tutorial on the payment function, the PMT function itself, and within that tutorial we looked at how to set up the PMT function in order to calculate the monthly payment for a new car. The scenario was, I want to purchase a new Infiniti QX60 Hybrid. The purchase price is $42,000 and I've saved $4,000 as a down payment. And the bank has quoted me a 4.25% APR for a 5-year auto loan, and my payments are made at the end of the month. So to review that formula, we'll look at our scenario. Here's the purchase price, the down payment. The loan amount, of course, shows you that we took the purchase price in cell K9, subtracted K10 to come up within the $38,000. Our annual interest rate is 4.25%, and the loan duration is in years. And so for our PMT function, the formula shows that we took K12, which is the annual interest rate, divided it by 12 to come up with a monthly interest rate that the PMT function needs in order to calculate the monthly loan payment. And then the second criteria was K13, which happens to be the loan duration in years. We want to multiply that by 12. 5 years times 12 months in each year means that we would have 60 payments altogether. And then the final criteria is K11, which was the loan amount. And notice that at the beginning of the function, we have the negative sign, and that's because the PMT function will return a negative number, and a lot of people like seeing a positive number instead, so that just reverses the sign. So for our amortization schedule, we come up with the knowledge knowing that we have a $704.12 monthly payment on our car. But after determining that, We want to see exactly how much of the monthly payment applies to the principal and how much of the monthly payment applies to the interest each time that we make a payment, and then of course the remaining balance on the loan each time we make a payment. I also want to see how much interest I've paid over the life of the loan and the total value of all payments over the life of the loan, which answers the question, how much did I really pay for the car? The amortization schedule answers all of these questions. So let's look at an amortization schedule. So for our amortization schedule, we have certain columns that we've listed: the payment number, payment amount, principal amount, interest amount, the balance, the principal paid to date, and then the interest paid to date. So we're going to begin with our payment numbers. Of course, we know that we are going to have 60 payment numbers altogether. I'm typing in the 1 and the 2, and then I'm going to select those two numbers and use the fill handle to bring down the remaining 60 payments. So we can see the 1 through 60 fill in. Then we're going to look at the payment amount. So the payment amount, although we know it's $704.12, we're going to use the financial function again to set that up. So I go to Formulas, and then Financial, find my payment function. The rate is the 4.25% divided by 12. The number of periods will be 5 years, which is in B33. Multiply that by 12, and then the present value is the $38,000, which is in B31. I'm going to click on OK, and as I mentioned earlier, by default, Excel will return a negative value, so I'm returning to the formula bar, typing in negative in front of the PMT to reverse the sign. Now I'm going to use the PPMT function to figure out, of the $704.12, how much was paid towards the principal of the loan. Once again, I go to Formulas, and then Financial, and then PPMT. The criteria required is very similar to that of the PMT function, with an additional piece of information. The rate will be, once again, the 4.25%, which is in cell B32, and I want to divide that by 12. And then the period. Now that's new. What Excel is asking for in this case is the specific period number for the payment that we're making, and this is period number 1. So I click on the 1, which is in cell A39. The NPER we've used previously is the total number of periods that are required for us to pay off the loan. So we click on cell number B33 and we multiply that by 12. 5 years times 12 months in each year would be 60 payments. And then PV is the present value, which is of course the $38,000. And we won't enter anything in for the FV or then the type. Both of those will stay empty, be omitted at this point. We're going to click on OK. And Excel returns in similar fashion to the PMT function a negative value. I'm going to reverse the sign. And we can see that for our first payment of $704.12, that $569.54 actually applies to the principal of the loan. Now we're going to use the IPMT function to calculate how much of the $704.12 was actually interest. I go to the financial functions and I select IPMT. The rate, very similar to that used in the previous functions, 4.25%, it's in cell B32, going to divide that by 12. The period number, once again, we're on the very first payment, so I'll click on A39. And then the number of periods will be cell B33, which is the 5 years, multiplying by 12, which will give us the 60 months. And then the present value is $38,000. And I'll click on OK. And of course, Excel returns a negative number. I'm going to reverse the sign. Now, for the balance, then we know that we've just made our first payment. And I should mention that if we highlight these two cells, then we'll see that the sum, if we look at our summary bar, is $704.12. So they do add to the payment amount. Sometimes you'll see maybe a rounding difference in one or the other of a cent or so, but it all works out in the end. So we go to our balance, and then our balance, because we started out with $38,000, we just subtracted a payment of $704.12. But to determine the balance, we don't take off the $704.12. We can only take off the principal amount. The interest amount is profit for the bank. So our principal amount is really what we're going to subtract from our beginning balance to come up with the balance that we see here. So I'm going to type in an equal, and then click on the loan amount, which is in B31, and then subtract from it the $569.54, which is our principal amount paid on the very first payment. And then we're also going to keep a running total of the principal paid to date and then the interest paid to date. So our principal paid to date after our first payment will be $569.54, which is in cell C39, and then our interest paid to date will be the $134.58, which is in cell D39. And now we're going to take a look at our second row. Now, first of all, we know that our monthly payment of $704.12 will be the same for each month that we pay off the loan. So that means that we can copy this formula, but before we do, we're going to adjust the formula to add our absolute references, because as we well know, if we copy this formula from row 39 down to row 40, it's going to adjust the B32 to a B33, the B33 to a B34, and the B31 to a B32, and then our formula will be incorrect. You can actually see what would happen if you just try copying. You'll notice that it's 2 cents, and we all wish that our monthly payment on our loans would drop from $704.12 to 2 cents, but clearly there's something wrong. So that means we're going to our original formula after clearing that out, and we're going to go up into the formula bar and then put on our absolute references on cell B32 and B33, and we're just hitting the F4 key on the keyboard to add the absolute reference. I click on each reference and then hit the F4, and that will make the absolute reference appear. And then when I copy my formula, we should see $704.12 appear all the way down through payment number 60. Now we're going to return to the top of our amortization schedule. Now, our principal amount has a formula as well. Let's take a look at it and figure out what parts of that formula will need absolute references and which ones will not. Well, remember that the PPMT function had an additional criteria, which was the payment number. And the payment number is shown in cell A39 for our very first entry. But in similar fashion to the PMT function, cell number B32, which represents the annual interest rate, should not be changed as we copy our formula down, nor should cell B33. That should stay the same, and so should cell B31. But we do want cell A39 to change. We want it to, on our second row within our amortization schedule, we want to pick up the payment number 2, which is in cell number A40. Therefore, I'm going to add the absolute references to the B32, and then add the absolute reference to the B33, and then add the absolute reference to the B31. But we will leave A39 alone so that it will adjust to A40 and then A41 and A42 as the formula is copied all the way through the 60th payment. Okay. And now we're going to take a look at the interest. And the formula for the IPMT function we'll also need to have some absolute references added. And it's very similar, of course, to the PPMT function. The one reference that does not need an absolute reference will be cell reference A39. We want that to change to A40 and A41, but we want the B32, B33, and B31 to stay the same. So I'll click on the B32 and hit the F4 key, and I'll do the same thing for B33, and then I do the same thing for B31. A39 does not get the absolute reference. Now I'm going to select the interest amount, bring it all the way down. Okay. And for our second row, we can see if we highlight these two numbers, and like I said, there is some rounding that you're not seeing, but if we highlight these two numbers, you can see in your summary bar that they come up to $704.12. Same thing is true for row 3 and row 4 and row 5. So now we're going to look at the balance function. So given that for our very first payment, we figured out how much balance would be by taking the $38,000 and subtracting from it the principal amount, which is the $569.54. For our balance after our second payment, we're going to take the $37,430.46 and subtract from it the $571.56. So I type in the equal. I click on the $37,430.46, which is in cell A39, and I subtract from it the $571.56, which is in cell number C40. And we can actually copy this formula down, because when we have the formula for our third row, it's actually going to be picking up E40 and subtracting from it then C41. In similar fashion to E39, subtracting from it C40. So this one will be safe to copy. And as we copy the formula down, what we notice is that when we hit row number 60, which is our last payment, our balance adjusts to 0, as it should be. When you make the last payment on your loan, the balance remaining should be 0 that you pay or that you owe the bank. And now we're going to work with the formulas for the principal paid to date. So the very first formula was simply picking up cell number C39. But for our second formula, we want to click on cell number F39, which has the amount of principal for our running total that we're going to keep, and then add to it cell number C40. So this reads equals F39 plus C40, and then we hit the enter key. And then this formula as well should be safe to copy down without adjusting any cell references. And so we can see that the balance is then on the principal paid to date for the very last payment, payment number 60, should reflect $38,000, as that is the principal, the amount of the loan that we borrowed from the bank. And now we're going to look at our running total for the interest paid to date. In similar fashion to the principal paid to date, we're going to type in an equal and then click on cell number, in this case G39, and then add to it for our second payment the amount of interest, which is in cell number D40, and then we're going to copy that formula down, and it will show us that we paid $4,247.39 worth of interest on the loan. So this helps to answer a couple of questions about how much did you really pay for the car. Well, one way of figuring that out would be simply to sum up then the $704.12, your monthly payment, over your 60 months. And of course we can use the auto sum to do that. And it returns $42,247.39. If you wanted to total the principal amount, we can use the auto sum there as well. And for the interest amount that's been paid throughout the life of the loan, you can auto sum that as well. And of course, if we look at these two numbers themselves, they should add up to the $42,247.39. So just as a cross check, I'm going to add them. And we now see that exactly as we expected, we paid $42,247 and then 39 cents. Other interesting information that you can obtain from the amortization schedule that might help you to make better financial decisions would be, if you're curious at a given point in time, let's say after your first year of payments, after payment number 12, what is the balance that you owe on the car? In case maybe you want to pay it off early, then you can see that the balance is $31,030.81. And of course it shows you as well after payment number 12 that you've paid off approximately $7,000. It's really $6,969.19, and the amount of interest you've paid at that point is $1,480.29. And the other interesting things that students find out is that when you're making payments on a house or car or whatever, most of your payment goes, let me just say that a lot of your payment goes to paying the interest in the early part of the loan, as opposed to the closer you get to paying the loan off, less money is paid for interest, and then more money goes against the principal of the loan. It's kind of a basic lesson in consumerism. And that ends our tutorial for the amortization schedule.